Alright, hi guys, welcome to our lecture 6, where we are going to discuss about the electromagnetic force. Now, in our 5th lecture, we talked about the weak force, where we discussed how weak force is able to stabilize unstable element. We say that when a weak force carrier W is attached to a downward quark, it's able to turn that downward quark into upward quark. And when it turns this to an upward quark, it means a neutron shall have been changed to a proton, and this change is accompanied by emission of an electron. And in the meantime, we produce a beta negative decay. That kind of element undergoes a beta negative decay. Now, in this lecture we are going to discuss about the electromagnetic force. Now, electromagnetic force is a force that acts between two different charges. It acts between two different charges. In other words, it either exists as a repulsive force or attractive force. It acts between charges of the same kind or charges of different kind. Also, it is a force that acts within the poles of a magnet. As you can see, we have the force acting between positive, the proton and electron here is an electromagnetic force, because there is some sense of force of attraction that is realized through the principle of coulombs. And then we have the force here again acting between positive and positive. What we expect here, we expect them to repel. In this case, we expect an attraction force. They'll be moving towards each other, but in this case, they'll be moving far off. Now, the like poles will always repel each other. If you take north pole and north pole of a magnet and try to form some magnetic field of kind of stuff, because they'll be repelling each other. Now, if you take a north pole and a south pole, then they'll be attracted together. What makes them get attracted is nothing but electromagnetic force. So clearly, it means that electromagnetic force either describe the force of attraction between an like charge or the force of repulsion between the two like charges. Now, it also explains the repulsive of the magnetic fields, as well as the attraction of unlike poles of magnetic fields. Now, what makes the difference here is just that magnets exist in dipoles and charges exist in ion that have some kind of discrete, in other words, some quantized packet of energy. Now, electromagnetic force can always be used to our advantage. We can use it to our advantage. Actually, electromagnetic force forms a fundamental core of human life, because through electromagnetic force, we are able to induce a current through a coil. Now, this principle of electromagnetic induction has formed a pivotal electrical power production, and it spans all the way from bicycle dynamo, windmills, geothermal. We have things like maybe hydroelectric power production, where a conduction coil moves around at high speed around maybe a solenoid, and then or a magnet, then it's able to induce current. That current is what is being stepped up, and then being transmitted to the supply grids for our own consumption and industrial use. Now, also, if we do opposite of what we have done, what is being done here, in this case, you are trying to you move a coil or a magnet within a coil of wire, then it induces an electric current. Now, if we pass a current through a coil and then we place a magnet or not really a magnet, but a magnetic material within inside that coil. Then that material is going to be magnetized, and a magnetic field is going to be formed. Now, fundamentally, this is what is being manipulated over and over to create even the images that we have in the radiology, and that is why it's also fundamental. That is why I started by discussing it from this level, from the atoms as we come. Now, the use of this manipulation, the electromagnetic force, the force as a result of division in poles, and maybe the induction aspect is used over and over in the radiology to produce images, not only in the CT and the X-ray production, but also it's spanned even to the MRI, and we'll be able to see how it's being used there in MRI, as we discuss deep into the CT and MRI physics. Now, these forces that are being produced, this induced current, it can be stepped up, or maybe let's take an example of an Ostal supply. Normally, Ostal power supply is around 240 volts, but the CT or the X-ray machine require huge amount of power in terms of kilovolts, not even 1 kilovolt or something of that kind, but thousands of kilovolts. So through manipulation of electromagnetic induction, we are able to step up the low voltage into higher voltage. As you can see, in this case, we have the primary coil, where the primary coil is having few number of wounds. And as you can see, the voltage supply or the current is very low. That is evident by the amplitude of this current. Now, when it is passed through a solenoid, then we are able to step it up. And the principle of stepping up, it means that the secondary coil is supposed to have a high number of wounds as compared to, or high number of turns as compared to the primary coil. Now, as you can see now, our output here is amplified. As you can see, the amplitude is higher as compared to the here. So this is one of the property of electromagnetic force that can be used to our advantage, because I've just said that the Ostal supply is very small. It supplies voltage in terms of voltage, 220 voltage. But when we move to the CT, we move to the X-ray. For us to produce that X-ray, we need very high voltage that is able to produce to burn the filament, to give us the thermal electrons, and then accelerate these electrons towards the anode. And also to make that anode more positive, we need power in terms of kilovolts. Now, what makes us to achieve that kilovolts is the step-up transformer. So the electromotive force is equivalently applied in the transformer to produce the voltage. So it means that we can produce high voltage. So it means we can use it to our advantage. Electromotive force, we can use it to our advantage to enhance operations that we are undertaking in the hospitals or in the industrial use. Now, one other thing that we need to take into consideration is that electromagnetic waves are always orthogonal. They are always orthogonal, or in other words, they are perpendicular to the magnetic wave. As you can see, we have the electromagnetic wave or field moving like this, and then we have the magnetic field moving like this, or magnetic wave moving like this. Now, the movement of an electromagnetic force or wave induce a magnetic field, and they move orthogonal. They are orthogonal. In other words, they are moving at 90 degrees. Now, The movement of electric wave induce the magnetic field, and the movement of the magnetic field induce an electric wave. Hence, this one facilitates the self-propagation. Actually, what facilitates the self-propagation of electromagnetic waves, as we normally know, that electromagnetic waves does not require medium for propagation. Now, what makes them to be propagated is that self-propagation, because as a electric field wave moves, or electric field moves, it induces what? It induces the magnetic field. And when that magnetic field also has moved, it will also induce another electric field. Now that pattern keeps on continuing without any need of any medium. That's what makes the electromagnetic force to move in vacuum where there's no medium. It's different from sound that requires medium and other things, but electromagnetic force, they're able to move as a result of self-propagation, and self-propagation is realized by the fact that a movement in electric field or wave induce an equal but orthogonal magnetic field, and that magnetic field also is going to induce another electric field, and then it keeps on changing like that. Now, normally we use as I had said that we use high voltage in X-rays. So in X-ray tubes, we accelerate the electrons. Normally, electrons are being produced within the filament, where we have our filament here. Electrons are being produced here after a supply of current has been made into it. Then through thermionic process, we are able to produce the electrons. Now these electrons, if they are not accelerated to the anode target, then their production is equivalently useless. But now we have to accelerate them, and the acceleration is done as a result of the potential difference that is applied to the anode target. Now the force of acceleration that we use is an electromagnetic force, because it is a force between two opposite charges. Now when these two opposite charges move, then it creates a kind of energy transfer. In other words, we are going to have these electrons will be moving at some certain speed, and when they are in motion, then we have a kinetic energy, and that kinetic energy is what we are going to transform or convert into heat and X-rays. Now that we all agree that energy can neither be destroyed or can be created, but it can be converted from one form to the next. Now, through this aspect, we are able to convert kinetic energy to heat energy and the X-rays that we really need for diagnosis and even for treatment. Now, what creates this kinetic is the electromagnetic force. Now, the stronger the electromagnetic force, the higher the kinetic energy, and the higher the kinetic energy, that one corresponds to the percentage, higher quality of the X-ray that is being produced. Now that X-ray that is being produced is just but 1% of the total kinetic energy, and that one also will be able to discuss as we move into our X-ray model. Now, in our next lecture, we're going to discuss electromagnetic spectrum. Now, in electromagnetic spectrum, here we shall see how to classify the members of electromagnetic spectrum. Now, thank you for taking time to be with me in this lecture. See you in the next lecture.